Guys, this is the Academic Chemistry video, Chapter 2, Section 4, Part 1. Today we're going to talk about the difference between physical and chemical changes, so what it entails and how to identify. So the first thing is a physical change. I'm going to start here because this is something you're probably more familiar with. So a physical change is when all substances maintain their characteristics. And what I mean is the properties of what makes up the beginning stuff is the same as what makes up the end stuff. Another way of saying that is whatever the substance is, or if you have multiple things are, when you start, that's going to be the same substances when you finish. So even if it looks different. So my example here is melting ice. This is a physical change because ice is water, and then when it melts, it's liquid water. So it was water when it started, it's water when it ended. There was nothing at the atomic level that changed. So ice cubes are H2O. Liquid water is H2O. So the chemical composition stays exactly the same in a physical change, but it looks different because the state changed. It went from a solid to a liquid. So you can think of other things like if you cut your hair, for example. I still have hair. It was still hair here, hair there, right? I just cut it off. But it's a physical change because it looks different because it's now shorter and they're in two pieces, but it did have a change, so it's just a physical change. So let's compare that to a chemical change. So in a chemical change, the characteristics of the substances involved are changed. So as in the properties are changed because a new substance is formed. The reason you see new characteristics is because the atoms, those little teeny tiny, beyond microscopic, like smaller than microscopic pieces, are actually rearranged. So here's an example right here. You start with hydrogen and another hydrogen and it reacts with oxygen. So this is a gas and a gas reacting with another gas. In the end, you have H2O, which as you probably know by now is water. Water isn't a gas, it's a liquid at room temperature. So the characteristics have changed. You don't have two gases anymore, you have one liquid. And that's because you have new bonds. So once you form new bonds, you have new properties. So notice hydrogen was with itself at the beginning, but at the end, hydrogen's bonded to oxygen. So the bonds have rearranged, the atoms have rearranged who they're paired with. So at the chemical level, this is different from what we started with. This is also known as a chemical reaction, and we're going to spend a lot of the year talking about chemical reactions and really learning to get familiar with them. So here you go for the intro. Whenever you have a chemical reaction, you're going to have the reactants. Those are the things that you start with. So those are shown on the left-hand side of a chemical reaction. This is hydrogen and oxygen. Those would be your reactants. And those react to form, or the arrow points that way, your products. Your product is your ending material. Whatever you have at the end of the reaction, that's your product. In a chemical reaction or a chemical change, the reactants are different at the atomic level than the products. Since they're different at the atomic level in a chemical change or chemical reaction, you're going to have different properties. Your reactants have properties, your products have different properties. There might be some things that stay the same, like for example, color for this one, hydrogen and oxygen are both clear gases and water is a relatively clear liquid, but gas is turning into liquid without any change of temperature. That's going to be a property change. So here it is written out, hydrogen, H2, and oxygen, O2. So here's your hydrogen, H2, and your oxygen, O2. React to form water, H2O. If you notice in the formulas, H2 is seen at the beginning, and it's not with anything else. O2 is seen at the beginning, not with anything else, and now you have H2O that's not observed at the beginning, so you know that this is a chemical change or a chemical reaction. Now there's going to be some evidence of chemical changes that you want to be familiar with. So the first is a release of a gas. If you ever see something just like starts to bubble up, you know that this is a chemical change. Now I'm not talking about something boiling. So that's totally different. That's because you put in energy. This is just things combined. There's no reason that you would expect it to release a gas and whoo, a gas is released. That's a chemical change. The other thing is a color change. If you mix two things and get a color that you didn't expect, that's obviously going to be your color change. A precipitate. If a precipitate forms, That's a chemical change. What is a precipitate? Well, this is a solid that forms when two liquids mix. So if you pour two liquids together and then you see a solid in there, that was a pretty big change. Something obviously changed at the atomic level, so that's a chemical change. And the last one is an energy change. And this is an unexpected energy change. So you didn't do something to make this energy change. What I mean by that is energy is taken in or released in some way. So for example, heat is released or taken in. And when heat is taken in, we call that feeling cold, but there isn't really cold. We'll get into that in the next section. So this means something, two things mix, and you didn't add any energy or take away energy, and it just feels hot or feels cold. It's almost by magic. Like you don't expect that to feel hot or cold. The other way that energy can be changed is if sound gives off. So some reactions are going to release a big popping sound, or you'll hear an explosion. That's a chemical change. And the last one is if light is given off. Now, this is a lot more rare. We're not going to do one of these this year, but there are some reactions that'll happen, and it literally everything starts glowing. So that's a pretty cool reaction, and it's pretty obvious. So let's see 3 examples of a chemical change. The first is burning wood. So if you've ever been to a campfire and you started with a log and you set it on fire, at the end you end with all this ash. So that's totally different than the log that you started with. That's a chemical reaction. A lot of times a fire or that input of all that heat can actually kickstart a chemical reaction that won't happen otherwise. If you just leave a log out, it's not going to spontaneously turn into ash, right? But it can do that, and the fire just gives the reaction enough energy to get started. You've probably seen your fruit go bad, like if you have an apple that you cut up to bring to lunch and then it is brown. Oof. So this is called oxidizing fruit. It happens when oxygen reacts with the fruit. I know personally this always happens to my guacamole, and then I can't eat my guacamole until I realized, hello, it's oxidizing, so all I need to do is separate it from oxygen. So if you want to keep guacamole nice and fresh, say you had a dish of it and you want to eat it tomorrow, you can actually put it in a Tupperware, just pack it on the bottom, and put a thin layer of water over the guacamole. That'll protect it from the oxygen. You then have fresh guac the next day. The only thing to keep in mind, if you do this handy dandy trick, the water does suck out the salt, as you saw in your separation lab, which is a physical change. So you would need to resalt the guac the next day. However, then your guac will not get oxidized or turn brown and icky because it reacts with oxygen in a chemical change. The other thing to notice about this oxidizing, you can tell it's a chemical change because the color changed. So your apple here was white, it's now brown at the end. So a chemical change happened because you know that because of the color change. The last example I have is a precipitate forms. Notice you have this liquid here, a liquid here, and when they come together, you've got a solid. It's kind of hard to see in real life, but that is a solid that's forming from two liquids. A lot of times these solids are kind of gooey because they're still like really submersed in that liquid, but it is a solid. If it seems a lot thicker, that's generally what the precipitate look for that or look like. That's what you want to look for. So you had two liquids coming together, and then you have this thick, almost gooey area. Some precipitates are going to be fully solid, like you can touch them with your fingers and they are hard like rocks, but generally they make this kind of gooey substance, and that's a lot of times if you have like a hydroxide, those make a lot of gooey. All right, so that is it for the notes for today, and I hope you have fun identifying physical versus chemical changes. Make sure you ask a teacher if you have any questions.